In 8.8, we are graphing logarithmic functions. So here is a little bit of background on what our log function looks like. For our domain, we have just log base v of x. It's going to be all positive real numbers. You're going to have an asymptote, which if you don't know what that is, we will see what that is along the x-axis. Our range is all real numbers, so that'll be negative infinity to positive infinity. And then for our basic function, our intercept is 1, 0. Now this can all change depending on what your log is. So here is a little review of vocabulary. If you don't remember any of these vocabulary words, I strongly recommend you write them down. So, graphing logarithmic functions. Here is our function and to help us graph the logarithmic function. Intercepts are where the graph touches the y and x-axis, so you can have a y-intercept and an x-intercept. Domain is left to right on the x, so that's on the x-axis, so how far left, how far right. Range is how far down, how far up, so on our y-axis. End behavior is where's the ends of the graph going. And asymptote, that is definitely a new vocabulary word we haven't talked about this year. It's a line that a curve approaches but never touches. So visually, this is what asymptotes look like. So we have these dashed lines. So you can have a vertical asymptote. And if you notice, these red functions are approaching those dotted lines or dashed lines, but they will never touch them. So the type of asymptote we'll see in logs are these vertical asymptotes. So our first function that we want to graph, f of x equals log base 2 of x plus 3. Now don't forget, you can use Desmos, so use it to help you with some of this information. For example, our intercept. If I graph this in Desmos, log, you want to go to functions, down to calculus, and this log base a. So our base is 2 of x plus 3. So our intercept is this dot that pops up right here, 0.125, comma 0. Our asymptote comes from inside these parentheses here. So since we have just x, our asymptote is at x equals 0. Now, if we look back at our graph to help us understand that, if we take a look, this graph is getting very close to 0 on the x-axis. However, it will never actually touch 0. So our asymptote is at x equals 0, so we would have this dashed line here to show our asymptote. And then we have that intercept about there. Our domain, because it never touches 0, is from 0, and then it will go on to positive infinity. So looking at this graph again, it won't go past 0 on the left, and since it won't touch 0, it was a parenthesis, It's going to go on for forever to that positive infinity. Our range, this graph is going down forever, and it's also slowly going up and up and up. So our range is negative infinity to positive infinity. So we're going down, getting really close to that asymptote for forever, and then going up. Now our end behavior, so as x approaches 0, because we get really close to 0, f of x, which is our y value, approaches negative infinity. And then on the right, we're going to infinity on our x. So as x approaches infinity, f of x, which once again is our y, is also going to infinity. That's how we graph our logs. So graphing using Desmos, and then finding that intercept. So this one is x minus 4, still with a log base 2. So now our intercept is at 5, 0. Intercept this. Right here. Our asymptote comes from in here. So x minus 4 and equals 0. So x can't equal 4. So I'm going to have that dashed line with our asymptote at x equals 4. So that means our graph is going to get very close to that 4, but never actually touch it. Our domain, the furthest left our graph goes is that 4, but it never touches it, so that's a parenthesis, and it's going to go on to the right forever, so to positive infinity. Our range, we're going down forever, so negative infinity, and we're going to go up forever, positive infinity. Our end behavior, the furthest left our x goes is that 4. So as x approaches 4, f of x approaches negative infinity. So notice these are matching up. As x approaches positive infinity, f of x approaches positive infinity. All right. Last example. So graphing using Desmos to help us out. So we have log base 2 of x. Our intercept is at 1. So 1, 0. Our asymptote, we look in here, so x can't equal 0. So that line is at x equals 0. Now drawing my asymptote. Our graph will get very close, but never touch it. Our domain, the furthest left we're going is 0, but never touching it, so that parenthesis. And the furthest right we're going is positive infinity. Range, we're going down forever and up forever. So as x approaches 0, f of x approaches negative infinity. As x approaches infinity, f of x also approaches infinity. And that's our graphing logs. And really use Desmos to help you guys graph these.